Welcome to Ask and Learn.
All right, guys, we're doing problem 62 of chapter 8 in Chemistry to Central Science. So for groups 3A to 7A in the elements of the third row of the periodic table and beyond, the octet rule is often not obeyed. Excuse me. A friend of yours says this is because heavier elements are more likely to make double or triple bonds. Another friend of yours says that this is because the heavier elements are larger and can make bonds to more than 4 atoms at one time. Which your friend's correct? Well, the first friend is actually wrong. The second friend is right. So heavier elements are more likely to make double or triple bonds. That's not really true. I mean, you do have lighter elements that do make double or triple bonds. Like if you go to the second row, you can find oxygen that's double bonded, and you can find nitrogen that forms triple bonds. So it's not true that heavier elements are more likely to form double or triple bonds. So your other friend says because heavier elements are larger and can make more bonds, more than 4 atoms at a time. Well, that actually is partially the reason. So, like for example, you can have a compound like xenon tetrafluoride. However, you cannot have a compound like neon tetrafluoride. And one of the reasons for that is the fact that xenon is significantly larger than neon, because as you go down the periodic table, your atomic radius will increase. So you can actually xenon has more space available for bonding than neon, so it's able to accommodate more elements, and that's what allows it to break that. So that allows it to break that octet rule. So, like, the actual physical dimensions of bonding are a very important and I would say somewhat underrated aspect of why these things occur. Like, it's just the physical dimensions of the bonds are not good for making more than 4 bonds if your atom is too small. You just can't accommodate it. But you can accommodate that with a larger atom.